Okay, so if you're done with the quiz, pass it over towards the middle. We're going to be using our computers today. I know I warned you about this. I think that you might be able to get by with your substandard computer if you have a substandard computer, but get it booted up, get it Excel ready, and you're going to go to our webpage to get started. Um, if you're not quite done with the quiz, don't panic. Get a feel for who's ready. Wow, everyone was quick. Put the staples. Nice. All right, let's just go over the quiz really quick, and then we will take a look at what we're doing today. So we have a little bit of stuff to take care of. Okay, so first off, this one is, yep, sound is going. So we're just trying to figure out, and sorry, it's a little askew on my image here, but you get the picture. Which one has the smallest mean? It's the one that is furthest to the left. The mean is the middle of the humps. And so A has the smallest mean. Oh, B and C look like they have the same mean. Okay, the largest mean is D. So that's the way I would do those. And then smallest standard deviation, that's the one that's the most compressed. So it's squished together. And that's this one here, C. You can't see the little line, but there was a little line. Oh, you can't see it on the, I'll have to make sure that on the actual test that it's a little bit more obvious. It's kind of hard to see the little lines. There's a line, kind of. It's there. But anyway, C is the one that's tall and skinny, so that's the smallest standard deviation. B is the one that's short and fat, that's the largest standard deviation. Common mistake is to switch those two. Just remember that standard deviation is how spread out you are. And so if you're smushed all together like C, you have a small standard deviation. Even though the hump is tall, it feels like that should be a big standard deviation, but it's not. It's a small standard deviation because it's all compact. Okay, now this next one with the bowling team averages 153, standard deviation of 14.5. So that's the way you would write that. You just put them in the blanks there. Mean standard deviation is the way that we do it. And then the z-score, just a review of what we did last time. So 175 minus 153 over 14.5. Whatever that is, I would put it here. I'm too lazy to do it right now. Although it's going to be a little bit over 1 point something. So if you got 1 point something, I'm sure you're right. You didn't get 1 point something. Let's see. 1.52. Someone got 1.52. Oh, yeah, a couple of people. So I'm going to go with 1.52. Here, I'll just put a star next to it, though, because I haven't double checked. I'll check with my calculator before I grade your quizzes. Okay, so for today, what we're going to be doing is we're going to be learning about how to use Excel to compute probabilities, the normal probabilities, and the binomial probabilities. So I'll need to remind you about binomial probabilities as well. But the first thing you're going to want to do is go to our Moodle page, go down to the Excel, where are they? I think I skipped it. There it is. Classwork Excel files. And we're going to be using the binomial normal classwork for today. So it's nicely labeled. So click that one, open it up in Excel. I'll give you a minute to make sure that it all looks good. I'll move mine over to the screen so that you can see what I'm looking at. There it is. Of course, enable content, whatever. Don't worry, I'm not trying to give you a virus. But this is what you should look like. I'll give you a minute to make sure you get it downloaded, put it into Excel, and then we'll do what we need to. Let's see. I need this too. Oh, that just got in the way, didn't it? Not to worry. There, that's what I need to do. Okay. Where is Excel? There it is. All right, so while you're, you know what, I'll give you another minute while I take care of my attendance that I still haven't done. I need to know who's not here. Give me a sec. So you're here, you're here, you're here, you're here, you're not here. Why not? I don't know. You're here though. Uh-oh, neither Caden nor Calvin are here, so even if I get them mixed up, I got them correct now. Let's see, Amy, Aubrey, just a sec. Blair, Kirsten, Carter, Briar, welcome. Kylie, you're here. Allie, Alana, Mason, I saw you already. Cooper, Evan. Mason, where's Evan? It's okay. Nevaeh, okay. I think, and Abby's here. Wait, Abby's, yeah, Abby's here. Wait, who usually, oh no, that's Calvin. Okay, it's not quite as bad as I thought. 1, 2, 3, 4, 5, only 5. It just feels like there's so much vacant space in here, doesn't it? Okay, I'm going to submit this attendance. People will start emailing me complaining that I marked them absent when they're really here. Okay, now we're ready to get going. So here's what we're going to do. So let's take a look at now all of these problems on this page. So this one is that you'll notice down here at the bottom, you have 3 tabs. Once we get through the 3 tabs, we're done for the day. So the first tab, binomial. These are all binomial probabilities. We've done binomial, at least we've done sort of binomial probabilities but we never did the actual calculations. I was saving it so that we could do it all together. And it looks like I spelled this wrong, whatever it is. But here, you can fix that if you want, but you don't have to. There, now it looks better to me. Okay, getting back down to this. We have a multiple choice exam. It has 25 questions, and each question has 4 possible answers. Immediately, you should think, oh, wait, this is a binomial probability, and n here is equal to 25, and p is equal to 0.25 or 1/4. Well, equals 1/4. I could do that, but 0.25. So I get that directly from the stem of the problem. That's the sort of thing you're going to have to do on your exam. You're going to have to add, I'll give you a problem like this, and I'll ask you, what is n, what is p? You remember doing this last week. Now, heretofore, what you did was you did this on your, on the Newton had the little, you know, the sliders, and you picked. Anyway, now we're going to see how we do this as Excel. And so let's go ahead and do this with Excel. And so I want to know the probability that you get more than 7. So the probability, here's the way I'm going to write this. The probability that you have, let's see, from 8, I don't want to write it down because I'll have to get some special characters. I'll write it down up here. Here's what I'm thinking in my head. X is greater than or equal to 8. Is that what it is? Just a minute. Let me double check. More than 7. More than 7 is greater than or equal to 8. It's 8, 9, 10, 11. All of those are bigger than 7. So that's what I'm looking for. So in other words, I want to know what is the probability that X equals 8 or 9 or 10 or 11, etc., etc. So we have a special way of doing this in Excel. This is a range of values. Range. It is a range of values that starts at 8 and ends at 25. You might say, well, how does it end at 25? It's because 25 is the most you can have right on a test that has 25 questions. So I'm going to use this formula, equals binom dot dist dot range. As before, I hope you appreciate how wonderful Excel is nowadays, where it gives you a little hint down here. It's like, I think you're probably wanting to do this. And it gives you this little hint. That's what you're going to do, right? Binom.dist.range. And then open parentheses. Back in the old days, like 15 years ago, we didn't have those little hints. So, I mean, it's so nice that it just gives you this little pop-up and it tells you, here, let's see, I can zoom in. Maybe, yeah, there it is. The zoom in, you can actually see. Look, well, maybe you can see it's still pretty small. Trials, how many trials? There's 25 trials. Probability of success. Look, it even says it there, probability S, success. The number of successes that we want. So that's what we're doing here. So let's do this. We're going to do the probability, let's see, binom dist range. We have 25 trials. The probability of success is 1/4. You can either type that as 1/4 or 0.25 or even 25%, as long as you put the percent sign there. So either one, any one of those will work. Now, as far as the number of successes that we're looking for, I'm interested in anything between 8 and 25. So from 8 to 25, whoops, there it is, from 8 to 25, close parentheses, press enter, and you'll get the probability. Let me zoom back out. And so the probability of getting anything between 8 and 25 questions right, if you guess, is 0.27349. By the way, this is the reason this has basis in reality. There was a test when I first was hired 27 years ago. Some of you took the trigonometry test. The trig test was 25 multiple choice questions, and you had to get 8 of them correct to pass. And I quickly realized that's stupid because someone could guess, and they have better than a 1/4 chance if they guess on all of the questions to get it right. So I forced my boss to revise it. Now you have to get 12 right, I think. It still is pitifully low. You would think you would have to know more trig to get it right. But anyway, at least it's a little bit higher than just guessing. You can't guess now. In fact, yeah, let's see. What is the probability of guessing now? So if we change this from 8 to 12, to pass the trig test now, you have to get between 12 and 25 right? Oh, yeah. Okay, a 1% chance it could happen. Probably not. Let me go back to make this 8 so that we have this for posterity. And I suggest that you save this somewhere because you will use these formulas on your homework. And if you're trying to figure out your homework and you're like, how do I do this? You can always go to these and double click your formula there and you'll see it. And you'll say, oh, yeah, that's how we did it in class. Okay, so let's go ahead and do the next one. And this one also is based in a real study. This was a real statistical study that was done recently about NFL coin tosses that in overtime, it turned, or not in overtime, yeah, in overtime sorry, I have to think of the specifics, in playoff games. In playoff games, in overtime, the team that won the coin toss went on to win the game in 72 out of 130 of the games. And it turned out that there's a slight bias because of the rules. I don't know what it is because I don't follow sport ball. But there's some sort of a bias in the rules for overtime in playoff games that biases the coin flip winner. I don't know if it's whoever gets the first goal, or touchdown. Whoever gets the first touchdown wins the game or something like that. I forget what the deal is. But there's some reason. I think they've changed the rules since then. So just recently, because of this study. But anyway, so this is what was going on. There's a probability of we think that if someone's tied at the end of the game and you go into overtime, that there should be a 50% chance of winning, shouldn't there, if everything's fair? And so we want to know, is that in fact the case? If you have two equally good teams, they both get the same score at the end, then you should think it's a 50-50 chance. So let's find out. So first of all, N is 130. P here is 0.5. We're assuming that there's a 50% chance of winning if you go into overtime, if you're equally matched, so to speak. So 50-50 chance because the coin flip shouldn't influence who wins. So let's go ahead and compute this probability, and let me write down the probability statement that I want. So back here, not there, just a minute, back here, what I'm interested now is the probability that X is between 72 and 130. Sorry about that. So it's the 72 and the 130 that are going to be what I'm interested in. Notice that in this case, because of the way the statement is written, I want at least. At least means greater than or equal to. In the previous problem, just to contrast, this one says more than. I know it's your algebra coming back to bite you. You hated this stuff. I know you did because I was there with you when I was learning algebra, and knowing that more than, that statement meant something. Whoops, that's the wrong thing. That's what more than means. And then at least meant something like this. So X is greater than, say, 10, or X is greater than or equal to 10. So if you have more than, wow, that looks bad. Make my X a little bigger. More than 10 would be X is greater than 10. At least 10 would be X is greater than or equal to 10. So hopefully you know this lingo, but just in case, it'll be a lot more helpful if you remember it. That's the difference between these two. Now let's just go ahead, crank this in. This is binom.dist.range of, let's see, I can see sort of, but I can't because I am old. So let's see if I can make this bigger. Yes, I can make it bigger. That's better. It says trials. We have 130 trials. There were 130 games that were studied. Probability of success, we're assuming, is 50%. And then we want to know the probability that anywhere between 72 and 130 of those games will be won by the team that wins the coin toss. And when you do this, the probability that you get is pretty small. I guess that's a roll of the dice, isn't it? 12%. But it's higher than lower than you would expect. So 12% is a pretty small probability. You would expect there to be a 50-50 chance of winning. So anyway, like I mentioned, because there were some researchers who did this study, the NFL, I think recently, within the past 3 or 4 years, changed the rules for overtime coin tosses. I can't remember the details because I don't care. Okay, onward. Let's deal with this. Okay, you know what? All 3 of these are ranges, so we need to do at least one that's not a range. I guess I thought I had enough examples here. We'll pull one up that's not a range in just a minute. I'll explain. Well, you'll see. Okay, but let's do this one. See if you can do this one on your own so that you have a scientist producing these pea pods. We're doing an experiment. And so I need to know, first of all, what is N and what is P, and then we'll do the calculation. We'll get those 2 first. I guess to do the calculation, I'm going to need to be able to write my statement in a probability statement like one of these. So take a minute and work through that or figure out what N and P are. I will find a random person to tell me what N is and what P is. Give me a sec. All right, Abby, what is N for this particular problem? 500, wait. Oh, yes, 588. I was thinking of the wrong number, so I was about to say the wrong thing. Very nice. 588. Let's crank it in here. 588. Very good. Because that's how many things that we are observing. We're observing that many in our sample, if you will. All right, next volunteer. What's the probability of success? AJ, what is the probability of success with this thing here? 0.25, very nice, because of course we're interested in whether or not Mendel's, that's basically based on Mendel's law, but Mendel's law for hybridization is correct. And those who aren't biologists, just remember 0.25. You just read it right off of that. You don't have to know about Mendel. So then we need a probability statement. So here, and this is a little bit confusing. So the probability statement is going to refer to this. So at least 152 have yellow pods. So we want to know, like, what are the chances? So if you would have done this experiment and gotten exactly 25% of your pods were yellow, then this would be the correct number. But of course, statistics or biology in particular, but any science is inexact. And so there's going to be a little bit of variation. So is this an acceptable amount of variation is the question. So let's go ahead and find out. I need a probability statement first, though. And so it says at least. So how would I write at least 152 in terms of a symbol? So let's see. Oh, you're not here. I know you know it, though. Gabrielle, do you know what symbol you're going to use for at least 152? Greater than or equal to. Very good. So in this case, at least, because it includes the 152, you're going to say the probability that your number is greater than or equal to 152. Now, I can't do that on Excel. Well, I could, but I don't want to show you how to do that one. Let's stick to the ways that we know. So we have the 152 down here, and then X, and then what's the max? 588? I think that's what we said. I'll double check back here. So that's what I'm actually going to compute. So this is a range. And so over here, I'll do my probability. Maybe I'll just write this probability. Probability is going to be equal to binom dot dist dot range. The number of trials, whoops, the number of trials was 588. Probability of success was 0.25. And I'm interested in anything between 152 and 588. Essentially, what I'm asking, the question that you're asking is, what are the chances that you got that many yellows or more than that many yellows? That's the correct way to think about this statistically. So it's a 33% chance, just a 1 in 3 chance. So it's not outside the realm of possibility. A 1 in 3 chance, that's not much at all. You pick a number between 1 and 3 inclusive, and I can guess your number a third of the time. So that's not all that impressive. In other words, this is probably just by chance. You had a few extras just because of the natural variability of the biological world. Okay, I neglected to, I thought I had everything squared away, but I neglected to put any probabilities that were not ranges. So we need another example here. Here, we'll just make one up on the fly. I was going to pull up Newton, but why do that when you can just come up with something using my bag of goodies here? So I have dice in my bag. Let's get my dice out, or at least a few of them. Come on. I have other toys in here, so I'm running. There we go. Got too many things. Okay, so here are some dice. Ooh, these are fun dice. Okay, let's do the round ones. So I've got these weird round dice that a colleague got for me at a math conference. Whoops, that one's broken. So here's 3 of them. So here's 3 round dice. I want to know, what is the chances if I roll them that I get exactly 1 red? So you see that they have 4 colors on them, and when I roll them, one of the colors will be up. It takes a minute. Oh, there's a red. So you have red, yellow, blue. If you can see it, if you can't, you'll just have to trust me. Red, yellow, blue. So 3 dice, what are the chances that I get exactly 1 red? Just like I just did. So let's go ahead and we'll do this up here. I'll just type just a brief explanation. So there are 3 4-sided dice are rolled, and that's red, yellow, blue, and green. Those are the 4 colors that you could put on the dice. And I want to know, what is the probability? Oh, I have 3, yeah. probability of getting exactly one red, question mark. All right, so if you've typed that in, great. If you haven't, don't worry. I will upload what I have eventually. Let me just merge and wrap the text there. Okay, so let's go through, get my N, get my P, and then I'll do the probability statement. And then I'll explain the difference between this and the range. So first of all, I need some volunteers. And I have my, nope, that's not my volunteer list. Where are my volunteers? Here they are. Okay, first one is, what is the N? So Kirsten, what is the N for this experiment? How many dice am I rolling? I've got, wait, I have 3. Yes, I can count them. They're right here, 3. Sorry, I was almost fooled by you. Yeah, they are 3. So N here is 3. So let's put N equals 3 for this. Now I need the probability of success. That means the probability of getting red on a single die. So let's find another volunteer. So Bailey, what do you think? If I roll this die, what's the probability of getting it red? 25%, 1 in 4, because there's 4 choices, 4 colors. And assuming that this die has been manufactured in such a way that all of the different colors are equally likely to be face up, then red is 1 in 4. So we're going to go with 1 in 4 for 25%, or 0.25 for P. Whoops, 0.25. If I can move my fingers correctly. Now let's do the probability statement. So here's the difference between what we've been doing, where we have ranges, and what we're doing now. So I want to know the probability that I get exactly 1 red. Exactly 1. Exactly 1. So that's the big difference, is back here, these are ranges. Now this is just exactly 1. So the way that you do exactly 1 is you do equal. So here I'll do the probability. Here I'll actually type it, x equal to 1. Okay, so the probability of x being exactly 1, you do binomial. Let me move this just a sec. Sorry. Now it's higher. Okay. So we do equals binom dot dist. Notice that when you type binom dist, you have 3 options that pop up here. Oh, negative binom dist. Don't do that. We don't want to be negative in here. So just do binom dist and leave it at that. So if you don't have a range, you just do binom dist. Now let's see. Most of this is pretty straightforward. The number of successes. Oh, this is different, isn't it? It's backwards from the way we had binom dist range. So this is the number of successes come first. So that's 1 success. And then the number of trials, there were 3 trials because I have 3 dice. Then the probability of success, 0.25. But then you'll notice that there's one additional thing that it's asking for here, and that's this thing that says cumulative. Now, cumulative refers to the cumulative probability, or the cumulative frequency, if you will. So you're familiar with that from, or at least some of you, that's like a thorn in your side from the making the probability distributions. There will be one on the test, by the way. So make sure you understand what cumulative frequency means. But anyway, so that's what that's referring to, is, are we interested in the cumulative probability or just the actual probability? I just want the probability. I don't want it to be cumulative. So I'm going to type false here. Whoops, you can't see it now. It's over there. So I'll type false. And in general, because we have binom dist range, we'll do false. I think that iPad boy might not have binom dist range on his iPad, in which case he'd be stuck with using, putting a true here for all of those ranges up there. It's more complicated though. So I much prefer using binom dist range to using the cumulative probability. Anyway, we're just doing a single. If it's exactly, you just put false there. Anyway, that's the way it's always going to look. Let me zoom back out so that we can see the whole thing. Whoa, that's not what I wanted. There we go. And then let's see, can I hit enter? Can. So it's a 0.42 chance. That's actually a pretty high chance, surprisingly high. So 42% of the time I should expect I should get at least, or exactly one red. Let's just do it one more time. And, oh, no reds. It's blue, blue, yellow. Okay, one more. I'm feeling lucky. There's one red, only one. So very nice. Okay, so that's the way that works. So when you see exactly, you're going to use binom.dist. If you see a range, binom.dist range. Okay, we're halfway done. We have to deal with normal curves now. So I have here on tab 2. So if you go down to the bottom here, see 3 tabs. The tab I'm interested in is the normal curve. The only reason I include that is because I know that you guys are too lazy to actually draw your normal curves. And so this will allow us to have a normal curve without having to draw it by hand. I'll still draw them up on my computer here or my iPad, but this allows you to have a normal curve. We'll refer back to that in a bit, but go on to the normal probabilities tab. That's the one that we're actually going to be working with today. So let's get rid of that, and I'll zoom in so we can see. Wow, so many questions. Okay, it's going to be all right. Feedback, come on, there we go. Okay, so let's deal with this. I guess I have to zoom out just a bit. That's okay. Okay, so I've got 3. Is it 3 or 4? There's just 3. Good, just 3. So let's work through this slowly. I'll do the first one for you, and you'll do the second one, and then we'll work together on the third one. Okay, so the first one, it says a bottling machine is adjusted to fill bottles with a mean of 32 ounces of soda and a standard deviation of 0.02. So this bottling, you can imagine this bottle's like going through a machine, pumping soda into them or whatever it is that's pumping into it. And some of the bottles will have a little bit more liquid. Some of them will have a little less liquid. I'm going to choose a bottle at random. So I'm going to go through each one of these. Let's see, number 1, I'll put over here. The answer is, what is X? X is the amount of liquid in one randomly chosen bottle. How's that? So that's what we're actually measuring. Identify X. In words, we're actually measuring the amount of liquid, whatever it is that we're putting in this soda. I don't know what it is. Maybe it's isopropyl alcohol. I have some quart bottles of isopropyl at home. But anyway, so that's what we're measuring. Okay, the second thing, we want to write this in terms of a normal distribution. So number 2, and I realize that now you can't see my words. I apologize for that, but it's trying to strike a balance between how zoomed in I am and the rest of it. So this X is related to the normal curve, and it's normal with, well, I could have asked you, but here it is. It's you put the mean first and the standard deviation second. Oops, I need another 0. There it is. So that's number 2. So you're going to have to do this. I don't know how much you have to do it on Newton, but for sure you'll do it for me on the quiz next time and on the exam. So you'll have plenty of practice for that. Okay, number 3. Number 3, we want to find the probability that the bottle contains less than 31.95 ounces. So to do that, here's how I'm going to do that. First of all, I need to draw a normal curve. Draw a normal curve. And don't worry, I'm going to show you how to do this on Excel because I put that tab in there so that you can have it there. Okay, so this is 32. That's the mean. Standard deviation was 0.02. So that means that this would be 31.98 and 32.02. So let me just remind you, the mean is 32, standard deviation 0.02. So far, so good? Now I need to actually write down, let's see, what do we have here? Whoops, no, there's what I want. I want to know the probability that the bottle contains less than 31.95. Okay, so let me put 31.95 on here. It's going to be over here somewhere, 31.95, and shade this way because it's less than that I'm interested in. So that's what I'm interested in. I want to know this probability. Let me show you how you would do this using my little tab on Excel, just to see how that works. Some of you have already done it. That's the way you are, I know. You've been fooling around with this. But let's see. So here is, look at this. Isn't this beautiful? I've got a place. All you have to do is enter the mean, 32, the standard deviation, 0.02. Wait, why isn't this changing automatically? I don't know. I'll find out. Maybe it's broken. That didn't change. Okay, just a sec. A is 0. I'll explain why in a minute. 31.95. It did not change. Why did this not change? What if I hit F9? Just a minute. Why didn't it? See, I've hidden some stuff over here. Did something go wrong? Hold on a minute. Let me go see what's wrong. Look, there's the numbers. Hold on a minute. Oh, those aren't right. What happened here? Oh, Brad. Oh, no. Those aren't right. Okay. Sad. Oh, well. Okay, I'll have to fix this and upload it. Apparently, all my formulas got flattened out to just be numbers. Oh, that's so sad. Let me see if I can show you what I had. Normal curve template. I think that's where I got this from. Yeah, check this out. So this, I must have, I don't know why it didn't copy over, but here's, let me copy these to show you what you'll, I'll upload the corrected version. Look at that. Isn't it beautiful? I'm just excited that I can make my own. Look, see, little tiny thing. Okay, there, you can do it by hand for now. There, it looks sort of like this, doesn't it? Okay, so what we're looking for is we're looking for this percentage. Take a guess. What do you think it is? 1%? 0.5%? I don't know, but you could take a guess, and that will help guide you when you do your math, when you do it on Excel. If you get a number like 90%, I'm pretty sure 90% is wrong. Okay, so let's get back here. Let's do this in Excel. Sorry about that not working. So you can just delete that, apparently, that whole tab. I'm just going to delete it. Delete, delete. It's gone. Let's get back to this one. Okay. So I want to do number 3. So the way I'm going to do it is I'm going to, first of all, well, I'll just do this. What is the probability that X is less than 31.95? 31.95. That's what I'm computing. And the way you compute this is you compute it by doing equals norm.dist. I know it feels really similar to what we did just a minute ago with the binom. Norm.dist. And then it says, let's see, I can't see because my eyes are not as good as yours. So let me zoom in. Let me zoom in. There it is. I knew it would magically do it eventually if I pressed the right button. Okay, so the first thing is X. The X refers to the number over there on the left in parentheses, 31.95. Now the mean, we all understand what that is. That's the mean of the distribution. Next is the standard deviation. That's 0.02. Finally, this cumulative. Now, unlike the binomial distribution, with the normal distribution, we do want the cumulative distribution because we want to know everything from 31.95 backwards, all the way down to a negative infinity. So that's going to be true. Another way to think of this is you truly want to know the answer. And so that's always going to be true, but that's only with binomial. So hit enter, and you should get a number like this. Let me zoom back out. There, it's back out. Okay, so this is one of 3 different types of probabilities you're going to have to do. Number 1, if the probability is less than a particular number, you're going to just do it like that with the norm.dist. See, there. That's kind of small, but hopefully it'll be okay. Okay, number 4. Number 4 is what is the probability that you are between 2 numbers? Ooh, I like number 5 first. I'm going to do 5 first. I'm going to put it down here. Why is it disappearing on me? I don't know. Well, I'll put it down here. Number 5. you need some room for number 4. So let's do 5 first. I want to know the probability that a bottle contains more than 31.97. Okay, so let's go back here and on my, not there, sorry, right there. On this, I'm going to superimpose the 31.97. It's right about here. And notice that what I'm interested in this problem, so this here is problem 3. This is going to be problem 5. I should have switched these two. I should have had 5, 4, and 4, 5. Doesn't matter. This is problem 5. That's the probability that x is greater than 31.97. Now here's the problem with Excel. Excel was written by Bill Gates. And you know what Bill Gates is, don't you? Bill Gates is a leftist. And leftists can't think about stuff to the right. And so this is an area to the right. Bill Gates couldn't program this into his Excel program. He only programmed in areas to the left. So if you just remember that Bill Gates is a leftist and these probabilities will always be to the left, you'll be okay. Because this is to the right, I'm going to have to do some little bit of manipulation to get the actual probability. So here's the trick I'm going to use. I'm going to follow Bill Gates to the left, and I'm going to do this probability first. So over here. So all the stuff that I've got navy blue there, that's what Bill Gates will give me. And then I'll just subtract from 100%. And then I'll be done. So that's the trick I'm going to use to get around the fact that Excel is leftist. So let's go ahead and do this. So number 5, here's the trick, is I'm going to do the probability that x is less than 31.97. To do that, I need another parenthesis, don't I? Let me fix it. There we go. So to do that, I could just copy this. Check it out. I'm going to copy, Control-C or Command-C if you're using a substandard computer, then Control-V. Anyway, I can just go and change this number to 31.97. And that's going to get me the probability that you are to the left of 31.97. So start off with that. And then to get the probability that you're actually bigger, x is greater than 31.97, you just subtract the previous number equals 1 minus the previous number. So you do 1 or 100% minus this answer. Oops, why do I have a parenthesis? I don't know. So that should be it. Why does this look wrong to me? 31.97. No, that's about right. Sure. I see. That's so low. It just, yeah. So that's the number you should get. I can show you. I can make this bigger. Look at this. It's huge. And I can show you the formulas if you need them, if you're stuck on either of them. So it's just 1 minus the previous answer. So that's the true answer to number 5. You're doing greater than 31.97. That's more than 31.97. Okay, last one. And then you'll get to do some yourself. That's number 4. So 4 is the hardest of the bunch, but it's not terrible. So this is the probability that you are between two numbers, between 32 and 32.025. Okay, so to do this, oh, that's a terrible normal. I can't, just a minute. That's pretty bad as well, but I'm going to just deal with it. So here's my normal curve. Okay, so 32 is in the middle. I'm just going to do this, 32.025. I realize that the actual standard deviation is 32.02. There we go. It would be right there. So 32.025 is a little beyond 1 standard deviation. So here is what I'm interested in. So this is between two numbers. So here's the strategy that I'm going to use. What I'm going to do is I'm going to do the probability for the bigger of the two numbers. Because Excel is leftist, it's going to give me the probability of everything to the left. Here, I will highlight that. Everything to the left is this stuff. right here. So that's my first move, is I will get the probability of everything to the left of the bigger of the two numbers. That's going to be pink there. And then I will compute the probability of everything that's left of 32. And that's going to be this stuff that I've highlighted in both pink and brown. So it looks kind of gray, doesn't it? So all of that stuff. So I take this stuff, and then this stuff, if I can subtract that away from the pink stuff, I'll get my answer. And that's the strategy that I'm going to use. So if you ever have to compute the probability between two numbers, what you'll do is you first of all find the probability x is less than the bigger one, 0.025, and then you'll do the probability that x is less than the smaller one, and then you'll subtract. I want to type the probability statement. I'll do it. Probability that 32 is less than x is less than 32.025. And then I'll put in parentheses, subtract, because that's what I'm doing. Okay, so you understand the strategy, I hope. Let's give it a go, see if this works. The first thing is I'll zoom in so you can see better maybe. Maybe I'll also widen this. There, now there we go. Wow, it really got wide. I don't want it to be that wide. There, that's better. Okay, so the first thing, this is going to be equal norm, not dist, of 32. Sorry, I wasn't looking. Norm.dist of 32. The mean is 32. The standard deviation is 0.02. And I truly want to know the answer. Now I'm just going to copy this down so that it's the same formula, but I'm going to doctor it up a bit because this next, actually I blew it, didn't I? It's this one that needs to be different. It should be 30.2.025. Got ahead of myself. The top one is 32.025. The bottom one is just 32. Whoops, I didn't mean to get help. I pressed the wrong button. Let's go away. And then I just subtract. So to subtract, I do the top one minus the bottom one. You should get 39.43%, 0.3943 as that one. So not too bad. How much time we got? We got 8 minutes. Okay, we've done just about everything that I want to do. There's one more thing, though, that it's going to cause you grief and sorrow on your homework, and I don't want you to be sorrowful. So let us skip down to the bottom problem here. So this bottom problem, you go ahead and fill in numbers 1 and 2. I guess you could also do 3, but the one that I really want to deal with is number 4. 4 is completely different from everything else that we've done up until this point. So let's see if we can do numbers 1 and 2 together. Well, 1, 2, and 3, those are easy. So I'll just write down numbers here. There's 1, 2, and 3. So let's deal with x here. This isn't going to take you long at all. Hold on a sec. Got to pick a rando. I know you're all excited. Next volunteer. All right, Cooper, what is it that we're measuring here? Like, what is x? What is it if you, like, what are the measurements that you're making?
The amount of household income.
Okay, so this is the household income. So specifically, we go to each household. We say, what's your income? What's your income? So x is the household incomes. So you would have one, I would have a household income, we each have a household income. Okay, very good. Now, we need to do this. X is approximately normal, and we need those parameters. And so I need to find 2 more people. You're not here, you're not here. You're here, but I've already bugged you. But Diego, I haven't bugged you. Diego, what is the mean that I'm interested in here? All right, very good. 28,000. Wow, this must have been written years ago. And then there, what's the standard deviation? 8,000. Very good. So it's good to write that down. In fact, you're going to have to do this. Now we need our probability statement. I want the probability of what? So how am I going to write this in terms of a probability statement? Pryor, what do you think? What's the probability statement here? Very nice. And so that's going to be the 100% minus thing. So the way we're going to do this is we'll do this. X is less than 40,000. And that's going to equal norm dot dist of 40,000. Make sure you get the right number of zeros and spell. Apparently I'm having trouble with norm dot dist of 40,000 and 28,000, 8,000, and we truly want the answer. Okay, so that isn't all that surprising. We're going to do equals 1 minus that. So that's not bad. It's number 4 that I want to get. So let's just take a quick look at 4 in terms of a picture, and then we'll show you how to do it. So the difference, I always think of this as being the Jeopardy. Like in Jeopardy, you're given the answer, and you're supposed to come up with a question. And so in this case, we're told that that percentage there, that is 1%. But I want to know what this number is down here. So you see how this is backwards from what we've been doing up until now? So to do this, we have to remember that Excel is leftist. So if 1% is to the right of what I'm really interested in, I'm going to use 99% with Excel. Now, by the way, I know some of you are probably reading this saying, why is 1% to the right? Well, check it out. I want to know the highest 1% of all household incomes. So the highest 1% is up here. So when you draw this, make sure it makes sense based on the words that you just read. Highest 1%, they're way up here somewhere, not down there. Some people put the highest 1% down here, not correct. Put it up here where it belongs with the high income earners. Okay, next, we're going to use a new function to do this one. So the highest 1%, you're going to use equals norm.inv. So norm.inv is the function that you use. And here I'm going to zoom in. Let's see, there's the button I press. Okay, now you can see it better. So it says probability. That probability has to be the leftist. It's a leftist probability because Excel, whoops, it's at 99%. You can't even see the rest there. So don't put 1% in there. Otherwise, you'll end up with a number that's way too small. So put 99%, 0.99, or 99 with the percent symbol. Okay, then the rest of this is straightforward. The mean and the standard deviation, close parentheses. You don't need to say true this time. And you get it, and that's 400 or 46,610. Yeah, this was a long time ago. The top 1%. Yeah, just to illustrate, if I did this norm.inv with 1%, 0.01, 28,000, and 8,000, I get a very different number, $9,000. So when you get done, this is one of the things when you draw your picture that really helps. Is that if you draw this, you're like, that number can be over here somewhere. So if you get $9,000, I don't think $9,000 is to the right of 28,000. It's going to be bigger than 28,000. 9,000 is down here somewhere. So draw the picture. It's so helpful. I'll see if I can get my thing working online. By the way, the last one, as long as we're almost finished here, if you take a look at this last one, it says, what is the 75th percentile for household income? So the 75th percentile, that means what household income corresponds with 75% to the left. So fortunately for us, 75th percentile corresponds with what Bill Gates thinks of probabilities. Everything to the left. Everything goes to the left. So number five is easy. Whoops, whatever. This is going to equal norm.inv of 75. Look, I'll even put it as a percent. 75%, and then 28,000, and then 8,000, and then close parentheses. Oh no, what's wrong with me? Oh, it's because I can't spell. I keep hitting the R before the M or whatever. There it is. There it is. So it's 33,395. I'm going to delete this just because I don't want it to confuse you. So there's the correct answers. We never did the second problem. You could always do that for fun. Anyway, the homework for Wednesday should be all stuff like this. By the way, Wednesday you'll get my quiz, which is you're gonna wonder, how are we gonna do a quiz without Excel if all this stuff's on Excel? Well, you'll see on Wednesday. And because it's the day before a test, on Wednesday I don't collect the quiz. So if you remember, that's my protocol. All right, I'm going to turn this off or stop the recording so that if you want to come chat, you can without